Okay, guys, this little section is going to wrap up our day. Let me give you the answers for the last section. That was a 689 torr and 150 millimeters of mercury. This was the diver one. This was the first one over water. So that should have been the answers that you got. Okay, so let's talk about mole fraction. Let me read a question to you, and you can jot it down as we go along. But this is what a mole fraction problem would sound like. A mixture of gas containing 55 grams of carbon dioxide, 19 grams of nitrogen, and 76 grams of oxygen have a total pressure of 1.9 atmosphere. What is the partial pressure of each gas? So what? How do we take the grams of a gas and find out what the partial pressure is? Well, we do that by finding the mole fraction. So here's our data, okay? We've got 55 grams of carbon dioxide. We have 19 grams of nitrogen. We have 76 grams of oxygen at a total pressure of 1.9 atmospheres. That's what the problem told us. So what we need to do is convert those grams into moles. We can't do anything until we do that. So let's do that first. Here we go. So here's how we do that. Okay, so we're going to take the 55 grams of carbon divided by its molar mass. That's 1.25 moles, right? 19 grams of nitrogen divided by its molar mass is 0.679 moles. And 76 grams of oxygen, 32 molar mass, 2.36 moles. So those are our moles that we have in here, right? This many grams gives us this many moles. So what does that mean? Well, that means total in this container we have this plus this plus this. That's how many moles we have. So we add all that up. Pardon me. We add all that up and we're going to get 4.29 moles, right? So we just add it all up. Well, now, mole fraction is the partial mole divided by the total number of moles. So we go back to our listing our gases. Take its partial mole, right? That's what we had over here, right? Our partial mole. The partial mole divided by the total number of moles. Partial mole, total mole. Partial mole, total mole. To get, this is our mole fraction number, okay? It doesn't have a unit with it. Moles canceled out, right? So it's just, that's our fraction. That's the part that belongs to each of these gases. All right, so now what do we do with that? Okay, now that we have the mole fraction, we're going to go back to our total moles, right? I'm sorry, total pressure. So we take the mole fraction, all right? And now here we're going to go. So we take the total pressure in the container and multiply it by the mole fraction. So carbon dioxide's mole fraction was 0.29, right? Here's the total number of atmospheres, total pressure, times, this should be multiplied. That dot is confusing, isn't it? Let's fix that. We'll do X's there. Times. Is that better? Okay. It looks like a plus sign. Atmospheres times this, okay? So now we're just going to multiply all that out, and that's going to give us the partial pressures, all right? So when we do that, we're going to get these answers, okay? So 1.29. So the carbon dioxide is adding 0.551 atmospheres of pressure. The nitrogen is 0.3 atmospheres. The oxygen is 1.05 atmospheres. And guess what? If we add these numbers up, what should we get? Well, we should get pretty close to, we better get 1.9 atmospheres. I wrote that backwards. 1.9, right? We should get 1.9 atmospheres because that's the total pressure that we started with, or within a reasonable close to that, right? So that's how you do that. If you're given grams, right? If we're given grams, we're going to convert to moles, right? And we take the total number of moles and divide that by, take the partial moles divided by the total moles. That gives us our mole fraction. Then that mole fraction divided by the atmospheric pressure, not atmospheric pressure, the pressure inside the container. And then that's going to give us our final answers there. And you can work backwards from that as well, right? Because we just have to know how those ratios work together, okay? All right, if you have any questions about that, give me a shout out. I'm going to be posting your test over the weekend. It is going to be online on mGrade. So if you have any trouble with that, let me know. I'll reset it for you. You can start over again. Know that some people are having better success in different web browsers. Just make sure you've allowed yourself enough time so that if you get hung up on it, I have time to clear it out for you. You can start again. If you totally bum out on not being able to take it online at all, let me know and I can find a way to get that to you by email. Okay? All right. Have a great weekend. Stay warm. See you soon. Bye.